Today, in Lesson 9.2, we'll be talking about surface areas of prisms and cylinders. I have listed all the formulas that we'll have in Lesson 9.2. I also have some more specific formulas for areas of polygons, which is what we use for the bases of these figures, that we did not do in the last chapter. So the area of a pentagon, instead of using 1/2 AP, you can use 5 seconds apothegm times side. And for the area of a hexagon, you can use 3 square root of 3 divided by 2 times side squared. So let's take a look at the net of a rectangular prism. With this rectangular prism, we have 1, 2, 3, 4 faces, 5, 6 faces. 2 of those are bases. If we open up this prism, you can see the faces here that we have and the 2 bases. One of the things I wanted to point out is because this is a regular solid, regular rectangular prism, and we call it, remember, rectangular because its bases are rectangular. This rectangle 1 is congruent to rectangle 4, rectangle 2 is congruent to rectangle 5, and the base rectangles 3 and 6 are also congruent. So looking at this same figure again, we have the total surface area. And in our formula, this will be called S sub A. In your book, it just shows S. But I will be using S sub A because we have so many S's in our formulas. I think it's important to delineate. And this is the way they used to do it a couple of decades ago. And so I think it worked very well. So S sub A, or the total surface area, is the sum of the square units needed to cover the lateral faces and the bases. So when we solve these figures, we'll be solving the whole figure and it will equal S. Now, S sub A, or surface area, equals lateral surface area. In your book, this will also just be an L, but we have lots of L's in our formulas, so it's a capital L sub A. And the lateral surface area is the sum of the areas of the lateral faces. So this blue rectangle here is your lateral surface area, L. And it is everything in the figure except for the bases. So what that leaves now is the area of each base, which is a large B, and there are 2 of them. So the total formula is surface area equals lateral surface area plus 2 times the base. So in any right prism, the length of the lateral edge is the same as the height of the prism. So looking at this blue rectangle again, which we now call L, it has a length, and that length will now be called capital H for height. The net of the rectangular prism shows that the lateral surface area, LA, light blue rectangle, so that's the light blue rectangle, can be found as the area of a rectangle, just like we have before. But in this case, we're going to be multiplying the perimeter. And so the perimeter actually equals the length A plus B and plus C plus D. Now, let me remind you that these are rectangles and opposite sides of rectangles are equal. So that means, and let me get my pen out, that this length is C and this length is D. And often in our drawings, you'll see they have lengths and then all of a sudden they won't have a length. Well, they're just doing that to make the drawing a little more visual. So if this length is C over here, it will be C over here. That means that these lengths also will be A and B. So one of the things you might want to do with your drawings when you first start is fill in all the lengths. And this length over here will be H. So if you don't have one of the prisms where all the sides are the same length on the base, then you will add together the lengths. So the base, perimeter of the base will equal A plus B plus C plus D. And this changes our formula now from just L sub A to perimeter times the height. This is the same as saying base times the height in our rectangle formula that we had before. So let me say that again. Instead of using base times the height, we're now using perimeter times the height. This brings us to our first theorem, theorem 9.2.1. The lateral surface area of a right prism is the product of its height and the perimeter of its base. So L sub A, or lateral surface area, equals perimeter times height. Now that perimeter sometimes will be something you can multiply. Sometimes you will have to add. Let's look at our first example. We have a right triangular prism. It's triangular because its bases are triangular. And there are some things that this drawing actually illustrates. One of them was on the top triangular base, which is congruent to the bottom triangular base. It's missing some of the measurements. So just for the sake of visuals, I'm going to add those measurements. And you can see that you have three sides of this triangle. This is a scalene triangle. They have different lengths. One side is 7, one is 8, and one is 10. And that will be the perimeter of this base, 8 plus 10 plus 7. The height, which is demonstrated on this side, will also be the same over here, and would also be the same at this edge, which is 20 centimeters. So finding lateral surface area, we take the 8 plus the 10 plus the 7 and multiply it by 20. 8 plus 10 plus 7 is 25. And 25 times 20 is 500 centimeters squared. So now we've solved for part of this problem. We've solved for the lateral surface area. Because remember, our goal is surface area equals lateral surface area plus 2 times the base. So now that we have this answer, we'll solve for the bases. And you only have to solve for one base and multiply it. This is a right prism, so that means both bases will be congruent. So we have a triangle, and this is a simple triangle we're going to find area for. And they've actually given us the measurement of the height, which is 5.6 centimeters. And we have the base of the triangle, which is one of the sides of this prism. So 1/2 10 centimeters times 5.6 centimeters is 1/2 of 56, which is 28 centimeters squared. So now we have the base, and what we're going to do is now add together 500 centimeters squared plus 2 times 28 centimeters squared, which is 556 centimeters squared. Now what I'm going to do on the next slide is actually fill in the problem and review it. So the perimeter, remember what the perimeter was? It was 8 plus 10 plus 7. And it was multiplied by the height, which was 20. And the 8 plus 10 plus 7 was 25 times 20, which is 500 centimeters squared. Now we're going to do the base, and the base is a height of 5.6 and a base length of 10. And that's confusing when I say it. You have large b and you have small b. But when you go ahead and solve for your bases, you're going back to your old area formulas. So this is 10 and this is 5.6, which will be 1/2 of 56, which was 28 centimeters squared. And now you can fill that into your formula. We had 500 plus 2 times 28, which is 500, plus 56, and that's 556 centimeters squared. Now let's talk about a right circular cylinder. Why are we jumping from prisms to cylinders? Well, prisms and cylinders are related. They both have 2 bases. So a right circular cylinder unrolls to become a rectangle, and the rectangle, this rectangle piece of the cylinder is actually our lateral surface area. It has 2 bases, but the 2 bases are circles. So the area is the height of the rectangle, and instead of a perimeter, we're going to have a circumference, C. So let me say that again. In our last formula we had pH, which was perimeter times height. In this one we'll have circumference times height because we're using circles. So using this information, the formula S equals L plus 2B can be used to find the right circular cylinder surface area. This is our same formula, but what's within the formula will be different. So that L will equal CH. So our theorem 9.2.2, the lateral surface area of a right circular cylinder is the product of its circumference and height. So to find the total surface area, you're going to add the lateral surface area to the areas of the 2 circular bases. So example 2, let's go ahead and solve this right circular cylinder. We begin with the lateral surface area, which is circumference times height. And remember, the formula for circumference is 2 pi r. So it'll be 2 pi r times height. And let's look at our circle. They gave us a radius of 6 feet. We have a height of 9 feet. So let's substitute our radius into the formula, which is 6, and our height into the formula, which is 9. And 2 times 6 times 9 is 108, and this should say pi feet squared. Now we'll find the base, and we're going to use the area of a circle to find it. So area equals pi r squared. So if area is pi r squared, r is 6, so pi 6 squared is 36 pi feet squared. And now we'll add those together. So our lateral surface area was 108 pi feet squared. Our base was 36 pi feet squared. And we need to solve for 2 bases. So 2 times 36 is 72. We add the 108 and 72, and it's 180 feet, pi feet squared, which would be approximately 565 feet squared. Our next theorem, theorem 9.2.3. The surface area of a cylinder or a prism is the sum of the lateral surface area and the areas of the 2 congruent bases. So now, in the same theorem, they mention cylinder or prism because it's essentially the same formula. It's just the pieces of the formula that will be different. And there are actually more specific formulas that we can derive in a few of our cases. So in your notes, this is exactly what you want to do. So I gave you a formula for right circular cylinder that was S equals L plus 2B. However, if we now derive this for the cylinder instead of the prism, we substitute CH for the L and pi r squared for the base. And if we go ahead and combine, well, first, if we delineate this piece, we can see that we've pulled out the circumference. And in this third step here, we still have CH, but now we have circumference times the radius. We can take both of these C's, use distributive property, and we now have a new formula for right circular cylinder, and that is circumference times the height plus the radius. And if you have all the information for this formula from the outgo of a problem, this you will find will be much easier than using this formula. Here's some other special formulas you can use. I won't derive these, but put these in your notes, and I would use these formulas instead of the S equals A plus L plus 2B. So for a cube, instead of saying sides, we say E for edges, and it will be S equals 6E squared. For prisms now, instead of S equals L plus 2B, you can say S equals the perimeter times the height plus the apothem. So if you have the apothem length, this works very well. Let's take a look at your homework. Lesson 9.2, we have numbers 1 through 2, 4 through 12, 9, 21, 38 through 42, 43 through 45. And let's take a look at some examples. So for homework examples, numbers 4 through 6, it says find the area of the base, then find the lateral surface area. They're switching around the order of what they were solving for from what they showed you in the lessons. You'll find your own method, but this is actually the way that I solve. I like to find my base first. So the base is something I'm familiar with. It's just finding the area of a polygon. So let's take a look at this base. It's a square. And the area of the base, it's a square base, is S squared. So we have a length of 12 millimeters. So 12 squared equals 144 millimeters squared. Now we can solve for the faces and the lateral surface area. The lateral surface area equals the perimeter times the height, so pH. Now this is a regular figure, and we have, for perimeter, you have, remember, number of sides times the side length. So there are 4 sides, and the length is 12. So 4 times 12, and the height is 25 millimeters. 4 times 12 is 48. 48 times 25 is 1200 millimeters squared. So in numbers 4 through 6, they're only asking you to solve these 2 items. They're not asking you to solve for the total surface area. So don't get yourself confused and solve for more than you need to. Numbers 7 through 12. Now they are asking for the total surface area, and we will solve for the whole problem. So in this figure, they switch again and they say solve the lateral surface area and then the base. I'm going to solve for the base first and use our new formula, which was the area of a hexagonal base. So it's 3 square root of 3 divided by 2 times side 2. You can see the side length is 8. So 3 square root of 3 divided by 2 times 8 squared. 8 squared is 64 times 3 square root of 3 divided by 2. And 64 times 3 is 192, square root of 3 divided by 2, which is 96 square root of 3. So your base is 96 square root of 3. Leave it in that form. The perimeter times the height. The perimeter, it's a hexagon, so it has 6 sides of 8 feet. 6 times 8 is 48, and we're going to multiply up by a height of 23 feet. 48 times 23 is 1104 feet squared. And then let's finish this problem. Solving for the total surface area, we now add the lateral surface area we just solved for. Here is our base of our hexagon was 96 square root of 3. We have 2 bases, so we multiply by 2. And 2 times 96 is 192. And this is 1104 feet squared. Just leave this in this form. You do not have to solve this down to a decimal. Here's some hints for the rest of your homework. For number 21, use the new formula for area of a cube and back solve to find E equals. So you're going to solve for E equals for number 21. Numbers 38 through 42, answers for some of these figures are in chapter 1.7. And you can also use the internet to search for answers. So they're asking for numbers of sides and so forth for hexahedrons. And we went over that in chapter 1. And most of the answers will be there. So that's the end of this lesson. Please call me or text me or email me if you have any questions. And we'll be moving on to 9.3.